Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing DevSecOps. So before we continue, let's track our progress so far. So our estimation completion date is 31st July 2024. Originally it was 2nd July, but due to my schedule we could not do it. So we are on track. I mean, by 31st July 2024, we'll be able to complete this path. So certificate progress is 82% and the next achievement will be terminated. Okay. So we already covered secure software development, security of pipeline module, security in the pipeline, container security as well. Now we left with just 3 rooms here in the infrastructure as a code, in which we will learn the infrastructure as a code fundamentals and best security practices to follow as a DevSecOps engineer. Okay. So once we complete that, officially we'll be able to complete and get the the badge for the DevSecOps path. But there are other rooms that we identified along the journey. We'll be covering Kite's best security practices, Kubernetes best security practices here. Then the Docker Rodeo. We'll cover the Linux fundamentals again. I will restart the progress on all 3 of these. Then we'll also cover the OWASP 10 2021 and the OWASP API security top 10. Okay, all of this will cover. And then we'll also cover the Solar exploiting log4j, then the sync open source, and the other room of the sync, which is also there somewhere. Okay. So thank you for joining me on this journey. So let's get into it. Intro to IaC, intro to infrastructure as a code. Let's see what we have here. Okay. So it will take 90 minutes. That means at least 2 videos will be there for this room, and they are giving us the badge for this room as well. So it's awesome. We have task 1 to task 8, so we're gonna cover I think task 1 to task 4 at least in this room, and once we come back we'll cover task 5 to task 8. So let's get into it. Introduction. If you aim to get into DevOps or DevSecOps, you may have encountered the term infrastructure as a code. Of course, this is because infrastructure as a code is a fundamental and integral part of DevSecOps. Due to the importance of this topic, there is no shortage of articles, blog posts, or paper discussing IaC, infrastructure as a code, or IaC, its various uses in the DevSecOps. However, these resources often brush past the many concepts and tools. This can leave DevSecOps newcomers confused over key IaC terms and lost on which IaC tools to use for what. This room will serve as a pace introduction to infrastructure as a code and walk you through these key terms, giving you a fundamental knowledge of IaC, which you can grow with the following rooms in this module. Okay, so this is TryHackMe. We have Schwarzenegger. He's a hacker, and the other IA is Bionic Eye. In the years of darkness, infrastructure was manually provisioned and configured. The rules of the tech world devised the ultimate plan. They would reshape the future by automating this process. The plan required something that felt no pity, no pain, no fear, something configurable. They created infrastructure as a code. I like that. Awesome. This was good graphic. Okay, learning prerequisite. This room will be continuation of the DevSecOps path. Yes, we know that already. So all the previous DevSecOps modules should be completed. Task 6 discusses the virtualization and specifically calls out virtualization and containers and intro to containerization for further context on this topic. So virtualization and containers, I don't know if we covered this one. Let's check it out. We did not cover it. Okay, so I will just put that in here. The modules that we need to cover. Intro to containerization, we have covered it already in this path, so you can just check the playlist. You will find some video related to intro to containerization. Learning objectives, understanding why infrastructure as a code is needed, understanding infrastructure as code as a concept, the tools used and their characteristics, understanding the IaC lifecycle and differences between provisioning and configuring, being able to identify tools for both, understand how fundamental virtualization is to IaC, understand the difference between on-premises IaC versus cloud-based IaC and the benefits of each. I'm ready to learn about IaC. Of course, I am. Okay, so move on to the task 2. We have 5 minutes into the video. So let's pick up our speed here. IaC, the concept, infrastructure before IaC. Before defining IaC, it's important to understand why we need it. In other words, what problem is it solving? Let us consider what was required when infrastructure was configured and managed in days before IaC. I don't know if I'm pronouncing it right, but I will say IaC, okay? Here are some tasks which would have been the responsibility of various teams depending on the company structure, such as DevOps, DevSecOps, platform, infrastructure, network, system administrator. It's pretty much the same thing, right? You have DevOps guy, DevSecOps guys, you have infrastructure, network, and system administration. All of these are there, unless you are on the cloud and you are managing everything, which have pros and cons, okay? Manually provisioning servers, physically installing servers, or manually deploying virtual machines. Network configuration, setting up a network for the infrastructure, including setting up IP addresses, subnets, routing tables, and any network components that the infrastructure needs, like routers, switches, and firewall. This still needs to be done on either side. I mean, even if you are on the cloud side, somebody will need to install something, right? But if you need to create a network, you will still be mentioning the IP addresses and all these things, right? Even on cloud. Installing an OS, yes, this is automated. Installing and configuring, updating of the software, this is also automated somehow. Database, web servers. Disaster recovery, this involves having a backup infrastructure on standby, making a detailed failover plan, and having clear procedures in place should the primary data centers go down. Yeah, this is also comes out of the box, I think, in the cloud environment, at least Azure have it. One is the main data center, the other one is the secondary data center. Infrastructure as a code explained. Okay, instead of provisioning and managing infrastructure manually, as discussed above, infrastructure as a code allows automation of these tasks through code. The code can be used to define a desired state, like Kubernetes, for the infrastructure, acting as a blueprint for IaC tools to provision the infrastructure. For example, we may define some resources in your code, such as network components, virtual machines, and databases. An IaC tool will build this blueprint and ensure the infrastructure is already in line with it. Should you want to make an infrastructure change, like increasing the number of VMs, only a simple change needs to be made to the code, which will be reflected in your infrastructure once applied. Compare this to what was previously required to add a VM, which would involve making a manual request through a portal and waiting for that request to be actioned by system administrator, and it becomes easy to see the utility of IaC. Of course, the many benefits of IaC. Okay, I'm scrolling down. Having infrastructure deployed from code also means it can be collaborative process and a shared responsibility. Okay, sometimes due to the domain of the company that you are working with, the shared responsibility is not the thing which everybody is comfortable with. So if they want to, be responsible, for example, for security, they will say, okay, we'll handle security from our side. Okay, shared responsibility comes in a broader way, right? You give the workshops and everything to other teams, so they know the pain points that we have, and if somebody wants to, for example, help us, they are welcome. Okay. So this is what we call shared responsibility. Not that everybody is responsible for everything. No, somebody will be owner of some particular domain, and all other people will help achieve their goals. Okay, this means knowledge of infrastructure and its configuration isn't siloed to a single team member, avoiding knowledge dependencies while supporting continuous integration. Conditional deployment is also supported through the ability to deploy consistent infrastructure across multiple environments, as well as reducing the manual efforts and risk of error, as an IaC approach can make it possible to have a reliable infrastructure that is scalable, versionable, and repeatable. And also, I mean, it really depends on your team. If IaC is because if you give in this infrastructure as a code to development team, they will create all sort of machines. Okay, so maybe it is not that wise decision to put everything on the development team. There should be some checks where basically you know that what you are deploying and how scalable your solution should be, what are the limits of your solution. Okay, and at the end of the day, there will be a bill attached to your infrastructure that you will create. Scalable. This technology begins to make even more sense when you consider the widespread adoption of the cloud computing and its elastic nature. Yeah, it's a widespread, but still there is a bill attached to it. With virtual machines and resource being scaled up and down based on the demand due to resource being built per second, minutes, and hour. Of course, with IaC, you can do this scaling with a single command or even automate the process, whereas in the past, this would have involved weeks of work. That is correct, guys. Logging tickets and manually provisioning and deprovisioning it, of course. And if you put everything, for example, if there is a shared responsibility, that means there will be a steep learning curve of all the technologies that you have and how you can provision it through IaC. And it's also depends on the environment, how mature it is. So we have examination list. They are doing something. Okay, so they created some IAC template, and now they are saying, okay, we are good. We are good. We don't have any work because we already created something here. I don't know if this is the intention of this graphic or not, but I I hope this is the correct one. Okay. Versionable. Infrastructure as code should be treated as any other code and versioned using a version control system. Versioning an infrastructure means it's self-documenting, allowing infrastructure changes to be tracked and recorded. This benefits the many teams that work with the infrastructure with all sorts of tasks, from audits to troubleshooting infrastructure issues. Speaking of infrastructure issues, versioning also means that that should your latest infrastructure start having problems, you can redeploy your infrastructure to the last known working version. An example of how IaC allows for reliable infrastructure. Versioning infrastructure can also improve testing capabilities. For example, an application can be tested using a historically infrastructure build. Sure, I will terminate you with affection. Okay, I think we better go back to the E800, E801. Okay, so E801 having some problems, so we are going back to the E800. Okay, let's move on. Repeatable. In the dev world, it is common to work between multiple environments. Developers first build their code in the dev environment before testing it in a staging environment. That is very true, which mirror production. And finally, deploying the full functional and tested code into the production environment. In the past, these three environments should require the manual provisioning and configuration of three respective infrastructures. With IaC, you can use the same code configuration to set up identical infrastructure across multiple environments with the push of a button. While saving massive amount of time, this also ensures consistency, reliability across environments, which is critical when testing software and was very hard to achieve in the days of manual provisioning. So in the DevSecOps, we understood the containerization and Kubernetes, right? And how to create this Kubernetes infrastructure itself. So this is how we will do. It will be done through infrastructure as a code. So there will be some template that we will run. For example, there's a new project and we need a new Kubernetes cluster. Okay, we don't want to use the old one. So what we will do, we'll save the template. We'll save the infrastructure as a template, and once it is a time, we will create the infrastructure from scratch. And this whole process is called infrastructure as code. So the template, we will save it as a code, as a the YAML file or something like that. So once we need, for example, if we need to test something before moving into production, we already have, for example, dev environment, staging environment, but we also want to have UAT, which is not there. So we can create it from scratch. Once we are done with the testing and integration and everything, business is happy, we can just dismantle this infrastructure completely and save the resources. Okay. So once we want it again, we can just use IaC to create the infrastructure again, and it will save a lot of money in that way. Okay. So it's all depends upon the environment that you are working in and how big it is. All right, which is critical when testing software and was very hard to achieve in the days of manual provisioning. Move on. I would like to deploy this infrastructure in the dev environment. I will be back. Okay, provisioning hall, configuration hall. What happened here? I don't know what happened here. Somebody, ran their card through the wall. I would like this same infrastructure deployed in the staging environment. All right, nice graphic. IaC in practice. IaC is a powerful technology that can streamline and improve business critical processes if used correctly. To demonstrate this utility, let us take one of the example responsibilities mentioned at the beginning of the task in disaster recovery, and examine how IaC can aid this process. As tasks on above, disaster recovery is the process of restoring infrastructure after a catastrophic disruptive event. For example, if you are working for a company that has a physical on-premises infrastructure located in a data center, a disaster can range from a simple power outage to extreme examples such as natural disaster like wildfires or hurricanes, bringing this primary data center down. Failing over from this primary data center to a secondary backup data center, when done manually, it is a very time-consuming and high-pressure situation which can lead to many issues. Here are a few ways in which IaC can help with disaster recovery. So, for example, if everything is down, and then business will be freaking out. You will be losing either money, face value, or the business itself, your reputation, name it. You name it. So an active data center should be there where your data at least is copied in a periodic manner. You need to define your RTO, RPO in this case, recovery time objective, and there is the other one, RPO, I think, priority, or I don't know what that. I don't remember now. So you need to define, and you also need to define how much data you can lose, and based upon these parameters, you define your disaster recovery plan, and also based upon these parameters, the disaster recovery, this data center itself will cost you more. For example, if you don't want to have any downtime, that means your disaster recovery will be behaving as a high availability zone for you, where the data will be actively will be copied to the disaster recovery of the second data center or secondary data center there. So based upon your requirements, you design your disaster recovery. Okay. So disaster recovery itself is, for example, if there is outage, your whole first data center is down. Uh, the operation should be, uh, uh, the should be you should be do the operations, and your software should be able to function on the disaster recovery data center, okay, or DR data center. Infrastructure automation, since IaC allows automation of the provisioning and configuration of an infrastructure, reprovisioning and reconfiguration and infrastructure is a backup data center. In a backup data center is streamlined and less time consuming. Yes. Disaster data backup and recovery. Data loss or corruption is one of the most significant risks associated with the data disaster recovery and can be very costly to affected company. Infrastructure as code can be used to automate the backup and recovery of data. Backup procedures can be defined in code, which will be triggered in event of a disaster to ensure data is restored. So all of this that you need to do, you should need to test. Okay, so disaster recovery is only as good as you last time tested it. Okay, if it is not working and something happens, that means your whole investment in the data recovery will be in the waste. Failover automation. During a disaster, critical services can become unavailable as they will point to the broken infrastructure. IaC can be used to automate the failover process, so critical services use backup infrastructure, which reduces downtime. Yes, of course. Configuration consistency. IaC keeps infrastructure consistent and well documented. This consistency is vital during the disaster recovery process and helps avoid misconfigurations, often caused by simple human error or lack of documentation on the current configuration. During the transition to a backup environment. Okay. All right. Scaling resources, the recovery process can be resource intensive, and IaC can be used to scale resources to handle increased workloads and scale back down afterwards. So what happens is, for example, if your main data center is running 10 containers, for example, so on the data DR side, you can run, for example, only 2 containers to save the money, save the cost on the resources. So once the actual event happened, you can always scale your containers from 2 to 10. Okay, because there is no active traffic on the disaster recovery data center there. So that's why you need to save the cost. There are just some examples of how IaC can aid and streamline processes with their wide range of teams benefiting from infrastructure as a code, versionable, scalable, and repeatable nature, saving them time and headaches. Because they are code, infrastructure as a code, so that means you can create versions of it, and once it is deployed, it's scalable, and you can repeat the processes wherever you want, basically, and that means it will save a lot of time and headaches. Getting it? Summary. In conclusion, infrastructure as a code is a fundamental concept in the DevSecOps, with the technology supporting key concepts like continuous integration, allowing for infrastructure development to be a collaborative process with versioning in place, continuous deployment, allowing for the automation of infrastructure deployment across multiple environments consistently. IaC also improves efficiency by facilitating infrastructure changes in the code, allowing for changes to be made quickly to adapt to developing infrastructure requirements and reduce manual tasks in the process. Awesome. Okay, so let's answer a few questions. We are already 24 minutes into the video, so I think I will take one more task before we close for today. Your organization is preparing to launch a new service called FlyNet. The DevSecOps team provision an infrastructure and tested this service in the dev environment with IaC characteristic. Will streamline the provisioning of this same infrastructure in this staging and production. So what is the question here exactly? Which IaC characteristic will streamline? Okay, which so it is repeatable, right? It is repeatable. Yeah, okay, so our streak is increased to 20. Awesome. It's the day before launch, and the latest infra change has started producing strange errors. Something about destroying humanity. Okay, weird. Which IaC characteristic allows us to go back to the last known working version. So it is versioning, of course, versionable. Awesome. It's launch day, uh, and it could not have gone better. The service is almost running itself. The FlyNet launch has attracted a lot of new customers, which IaC characteristic enable us to increase the resources available to our infrastructure to meet this increased demand with ease. So it is scalable. Awesome. So let's see what we have in task 3. I hope it is not that. Okay, so it's all theory. So let's cover it in this video. So once we come back, we'll cover task 4. Okay, let's continue. So IaC, the tools, part 1. Get to know your toolkit. Sure. Now that we have established what IaC is, we can start thinking about some of the tools used for infrastructure as a code. Many tools fall under the IaC umbrella, including Terraform, AWS Cloud Formation, Google Cloud Deployment Manager. Okay, where is Azure, man? Ansible, Puppet, Chef, SaltStack, and Pulumi. Wait a moment. Where is AWS? Okay, maybe it is Terraform. It's important to understand that some of these tools have different use cases, each with its own benefits. Due to varied use cases of these IaC tools, having infrastructure provisioned, configured, and deployed end-to-end will require using a combination of IaC tools rather than a single solution. To better understand these tools, this task will cover some of the key characteristics which distinguish these tools from each other, so you know what tool to use and when. Bear in mind that the behavior of these tools can often depend on exactly how they are used, often leading to debate over some of their characteristics. With this in mind, we will define those characteristics in question and how each tool is generally used. Awesome. Declarative versus imperative. Okay. First off, let's establish the difference between declarative and imperative, also known as functional and procedural IaC tools. Okay, declarative. This involves declaring an explicit desired state for your infrastructure, min, max, resources, X components, etc. The IaC tool will perform actions based on what is defined. A state file is kept to ensure your infrastructure's current state matches the desired state. In other words, it focuses on what rather than how. A declarative IaC tool is usually idempotent. I don't know what does that mean, meaning the same result will be achieved when run repeatedly. Okay, awesome. This is because the check is done against the state file, and if the infrastructure is already provisioned, it will make no changes if rerun. Examples of declarative IaC tools are Terraform, AWS Cloud Formation, Pulumi, Puppet. Ansible also support declarative as well. So desired state is 0. Exterminators, no exterminators present. Destruction not necessary. Okay, awesome. So this is what they do the analysis, and they say, okay, there is no need to destroy anything here. Imperative. This approach involves defining specific commands to be run to achieve their desired state. These commands needs to be executed in a particular order. Imperative IaC is usually not idempotent in that if you run these tools multiple times, the same result won't be replicated, or the tools may run into some configuration issues. This is because these commands will be run regardless of the state of your infrastructure. So running this command on an already provisioned infrastructure may cause additional unwanted infrastructure to be added, or may break the configuration of some existing components. Depending on the setup of the infrastructure and the commands being run. Examples of imperative IaC tools. Chef is the best example of an imperative tool. However, Salt, Stack, and Ansible both support imperative programming as well. Okay. So I think I will go with declarative because if you run it for multiple times, same infrastructure will be created and you are okay. There is no breaking configuration changes. But in imperative, there are breaking configuration changes, right? So I am more inclined towards the declarative tools here for IaC. Imagine it like direction to an X on a map, where imperative will give you a list of directions which will bring you to X if you are at the known starting point. For example, an unconfigured server. However, if you are not at this known starting point, e.g. a partially configured server, you will not arrive at X, but somewhere slightly different. Declarative takes into account where you are on the map and works out which direction needs to be taken to get to X from that point. Deciding which to use can depend on what your infrastructure needs are. Declarative is considered a more straightforward approach that is easier to manage, especially for long-term infrastructure. Of course, we implied that already. In contrast, imperative IaC is more flexible, giving the user more control and allowing them to specify exactly how the infrastructure is provisioned. Apologies, guys. I'm feeling tired here. Tired and sleepy. Provision managed rather than the tool itself taking care of it. We need to be consistent regardless. Initiating destruction step, destroy. All right. Agent-based versus agentless. Yeah, this is another very big concept. Agent-based versus agentless is a term that extends beyond infrastructure as a code and is also used in the context of monitoring security tools in the context of IaC. Agent-based, an agent will need to be installed on the server that is to be managed. It runs in the background and acts as a communication channel between IaC tool and the resource that need managing. The agent is responsible for executing and reporting on the state of the infrastructure managed resources. Note that this agent must be installed on every target system node that needs to be managed. An agent-based IaC tool can perform tasks even when the system has limited connectivity or is offline, making it a robust choice for automation. However, you need to take care with the maintenance when using these tools, monitoring the agent software closely so it can be restarted in the event of crash. Of course. Another thing to consider with the agent-based IaC tools is that some of these tools will require opening ports on the server for inbound and outbound traffic so that the agent can push-pull configuration information. From a security perspective. More open ports are negative, of course. You don't want to increase your surface area, attack surface, okay, or attack vector. Despite this, they offer a level of granular control over managed resources and can collect more detailed monitoring data. Because of this, they might be ideal if control is an important factor in your setup. Some agent-based IaC tools, Puppet, Chef, and Salt, Stack. Install the agent. Agent acts as an intermediary. You need to destroy one exterminator instance. They'll say, okay, we'll do it. Change config actions. Agentless. Okay. Agentless IaC tools, as you may have guessed, do not require agents to be installed at the target system. Instead, these tools leverage existing communication protocols such as SSH, WinRM, or Cloud APIs to interact with and provision resources on the target system. Agentless IaC tools benefit from being easier to use. Their simplicity during setup can mean faster deployment time, and their agentless nature can also mean the tool can be deployed across multiple environments without custom agent changes needed to be made based on each environment. needs, making it a flexible choice. Also, compared to agent-based IaC tools, there is less maintenance and risk surrounding the security of an agent. However, agentless IaC tools generally have less control over target system than the agent-based tools. Agentless tools are useful in the environment which have to adapt to fluctuating workloads, which with resources being created or destroyed to meet these workload. These newly created resources can be managed without having to rely on pre-installed agents. Agentless IaC tools, Terraform, AWS, CloudFormation, Pulumi, or Ansible. No agent install. I swear some guy just appeared out of nowhere. Just wait, I am not crazy. Communication done through pre-existing channel, which is API. We need to destroy one exterminator instance. Changes and configuration is done through the API. Once again, both options have their advantages and disadvantages. Infrastructure providing and configuration can present developers with a very particular set of problems, and choosing the correct tool for the job depending on what needs to be done involves taking these into the account, and also the licensing and also the tools availability. Okay, in this scenario given, which type of IaC tool, consider where you are on the map and gives the instruction to reach to the desired point. So it is there is agentless and there is agent based. So it is agent based. Let me copy it. It will automatically basically calculate where you need to do and where you need to go. What? Consider where. Okay, so it is agentless. What I'm not doing it right. Agent based or agentless. Okay, wait. Both consider it, but I don't know what they want me to enter here. This agent based then. It is not agent based. It's declarative, man. Come on, you guys are not telling me. All right. So it is declarative, guys. Awesome. So we are done with the task 1 to task 3. So once we come back, we'll start task 4. Thank you for joining me on this journey, guys. If you have any comments, please put it in the comments down below. If you haven't subscribed, please subscribe. Give it a big thumbs up if you like the video, and I will see you in the next video. Stay tuned. Bye.